Okay, quick one. Solution to question 2. I really don't need to go through the questions. You should read it. I'll just go straight to the solutions. Um, just as I speak, you see the question on the screen. You can pause it, you read it very well, and then you tend to understand it. And like I said before, right, in anything like business statistics like this, or even in statistics general or mathematics in general, please, once a topic has a formula, make sure you know this formula. Formulas are like key to open a locked door. So once you don't know the formula, the course becomes very difficult. So ability to state the formula and follow it, that is one matter. Now we are asked to use the z-test, okay? And the z-test formula says z is equals to x minus your mu over your standard deviation. Is that okay? Now what this means is that your mu is like your mean, is given in that question. Your standard deviation also is given in that question. So the x value is what we will now be imputing to get what we are. From the question, your mu is 100. Your standard deviation is 20. If you read the question very well, these values were given. So all we will do is just to impute. But on A says when x is greater than, calculate the probability when x is greater than 120. Is that okay? I'm going to impute all these values into this to get the z-score. So z will now be equal to, our x now is greater than 120, so we'll put our 120 minus our mu, which is 100, then divide by our standard deviation, which is 20. So if you simplify this, 120 minus 100, you have 20. So z-score will now be 20 over 20, which is equals to 1.0 if possible. Now there is something I want you to know, right? That in statistics we have statistical table, a standardized statistical table, where you can get your z-score. From there you can get your chi-square score also from there, right? So now what we are going to do is this. The value for this z-score is what we will be making use of, which is the probability of x greater than 120. 120 is the same thing as 1 minus this value you have from the statistical table. Okay, so how is it going to be? 0.8413. Then x greater than 120. If you do this subtraction, we are going to have 1587. So this is the value for x greater than 120. Okay, and the questions further say that you should show a normal distribution curve that simplifies, that shows this value. And for a normal distribution curve, it's going to be something like this. Okay, so let me just simplify. Here will be 120. For a normal distribution curve, this curve will not touch this line, so take note of that. 120 greater than 120, right? But this is 120, then you're going to shade all these parts. So you shade all these parts. Remember, this is the center. The center can be 100, okay? 100, 110, 120, like that. Then you can decide to do this 50 and the rest of them, okay? So this is the shaded part you are asked to show using your normal. This is x greater than 120. See, when p, that is the probability of 80, is less than x, and x is greater than 120, we're going to have two z-score. So refer to it as z1, which is going to be 80 minus 100 over 20. And then we're going to have a z2, which is 120 minus 100 over 20. Remember, if you simplify this, this is minus 20 over 20, which is minus 1.0, and this is the same thing like what we did the first time, 20 over 20, which is 1.0. So we have two z-score. We have to look for the values for minus 1 and plus 1 is different in that statistical table, right? We already have this, so we need to look for this. Is that okay? So probability of 80 less than x, then x greater than 120 is going to be the same thing as the value for 1.0 minus, that is the minus that is constant, the value of the z-score for this negative, okay, then it's going to be minus 1.0. Now remember the value for this one first, the one we did then. If you do that, that will be 0.8413, I guess, then minus 0.1587. So when you do this subtraction, you're going to have a 0.6827. Okay, this is the result you get for the B part of the equation, of the question in question 2. Please take note of this. Remember, they all boils down to the formula as well. Okay, so the next thing we're going to do, we're going to plot the normal curve. So the normal curve, like we did on the first one, is going to be the same thing like this. Okay, and then can label here 80, remember, and then can label here 120. The center can take 100. So what that means is that you see this point and this point, so we're going to label or shade all this portion. Okay, so this shows the normal curve. Is that okay? So please take note. Now the next one we'll be doing is the C part of question 2, and then that will be all for that question. So this next one says probability of x less than 60. So you know what that means. First off, we use our z-score, which is x minus mu all over standard deviation. We have this is 100, this is 20, and this is 60. So it will be 60 minus 100 divided by 20. So if you do that, at 60 minus 100 you have minus 40 divided by 20, then minus 40 divided by 20, that will give you minus 2.0. That means our z-score minus 2.0. Now if you go to the z table and search under minus 2, then you have 0. You are going to have 0.0228. This is the value you are going to get. Is that okay? Approximately 0.0228. So once you've gotten that, you've gotten your answer, you've gotten what they asked you to look for. The next thing is to represent this using your normal curve. Like I told you, the normal curve will come this way. But since it is less than 60, here can be 60, this middle can be 100, and so on and so forth. But this part that is 60, okay, let's shift it a bit so we have enough space. So here is what you are going to shade. This is 60. So this is probability of x less than 60. Now this is what you do.